All right, we are going to go ahead and work on applying the Pythagorean theorem to real world scenarios. So the first question says the triangle has a height of 3 feet. Find the value of n. So as you can see on my triangle, I have two sides that are n, but I only need to find one of them. You might also notice this looks, well, it's not a right triangle, so it could either be maybe a isosceles triangle, it could be an equilateral triangle, but remember this only works for the Pythagorean theorem on right triangles. So we kind of might want to look a little closer to see if we have a right triangle in this picture. And hopefully you notice if I cut this in half, here I do have a right triangle. Okay, you can do either the left side or the right side. So I just happened to pick the right side, so I'm going to consider this the right triangle that I'm going to work with to find my n value. So here we have a right angle because this is the only one that makes a perpendicular line. Okay, so we have a vertical and a horizontal. That makes your your right angle. And so it said in the answer that we had a height of 3. So our height means from the top of the triangle to the base of the triangle. So that number they gave us was 3. So if I kind of write it like this and draw it separately, it might be a little easier for you to see. And that's my height 3. And again, if we recall from our last video, our right angle make up the adjacent sides of the legs, which are A and B. So I also have this value here I need to figure out. You might think it's 8 because they gave us the value of 8. But in the picture that they gave us for this triangle, they said 8 indicated the base of this triangle. I'm not using the entire base of the triangle. I'm simply just using this portion of the right triangle. So how much is that going to be? Well, if I know 8 is all the way across and I cut it in half to make a right triangle, that means this side down here is 4. So remember, this is our right angle, and across from the right angle is our hypotenuse. And so our n value that we're looking for is actually c in the Pythagorean theorem. So I have 3 and 4 that are going to be a or b. So we're going to go ahead and fill in our formula. A squared plus b squared equals c squared. And we're going to fill in 3 as our A, 4 is our B, because remember those are the legs, and C, our unknown, is our hypotenuse. So 3 times 3 is 9, 4 times 4 is 16, and C squares are still our unknown. So we're going to combine like terms on the same side. 9 plus 16 makes our 25 equals C squared. I'm not looking for C squared, I'm looking for simply C, which represents the n value on our picture. So C squared is C. And the square root of 25 is 5. So my side length, the side length of the hypotenuse is 5 feet. So our answer is B. All right, the next one. It says Kate needs to travel from point A to point B. How many miles shorter, that's probably an important keyword that we're going to come back to, is it if she decides to take the shortcut through the grass instead of staying on the road? So you might notice that this is our road. Okay, so she has two options. She can go from point A to point B by traveling on this road, or she can take a shortcut. And the shortcut to go from point A to point B is going to make the distance here that's not created. And if you remember, this is Pythagorean theorem, so you should know that we're going to be making a right triangle. So you can hopefully see that right triangle, which means our right angle's here because that's our horizontal and vertical lines are meeting, which creates that perpendicular line. So this is our A and our B value. And we don't know the diagonal, which is going to be the length of C, the hypotenuse. So step 1 is always going to be using the Pythagorean theorem. And then we're going to readdress the question to make sure we're doing everything correctly. So I said A is going to be my value of 5. That's one of the legs. 12 is my other leg, so that's my B value. And C is our unknown, so we're going to leave that as C squared. 5 times 5 is 25. 12 times 12 is 144. And that's our unknown for C squared. So we're going to go ahead and add up our 25 and 144. They're on the same side, so they're like terms. That becomes 169 equals C squared. And again, I'm looking for C, but not C squared. So we're going to do the inverse of squaring, which is square rooting. And so that gives me square root of 69 is 13. So that gave me this distance, which is 13 miles. Now, we're going to readdress this question because it said, how many miles shorter is it if she decides to take the shortcut? Well, our shortcut is 13. This is the shortcut. And it said, how much shorter is it if she goes through that shortcut with the grass, or instead of staying on the road? Well, if she stayed on the road, how long did it take her? Well, we went from point A, and on the road, remember, this is 12, and this is 5. So how long did it take her to get all the way from point A to point B using the road? Well, hopefully you realize you're going to do 12 plus 5. That gave us a total of 17 miles if she took the road. Well, remember, we said the shortcut was only 13 miles. So how many miles does she save? Well, we can simply just subtract those. 13 from 17 is 4 miles. So our answer is C, 4 miles. All right, next one. All right, next one. It says a giant redwood tree fell during a storm. The place where it cracked, so we're going to look for that, the place where it cracked here, is 28 feet from the ground. Well, the ground's here, so that means this distance is 28. So we're going to go ahead and label that as 28. Then it says, and the top of the tree, well, remember it broke, so the top of the tree now is on the ground. So the top of the tree is 96 feet from the base. Well, where's the base of the tree? Well, the base of the tree is where it's growing out of the ground. So the growing out of the ground came here. So that means this distance is considered 96 feet. So you need to look for where your where your perpendicular line would be. So it's not going to be here. That's not a 90 degree. That's also not a 90 degree. So hopefully you realize this is our 90 degree angle. Once we identify this is our 90 degree angle, that means I know my legs are adjacent to that angle. And across from it, remember, across from the right angle is the value of C, our hypotenuse. So we're going to go ahead and fill in our formula, and then we're going to redress the rest of that question where it asks how tall was the redwood before it fell. So we got a squared plus b squared equals c squared. So a squared is, we're going to call it 28 because it's one of the legs, 96, which was our other leg, and then those are going to equal our c squared, which is the hypotenuse. So step one is we're going to do 28 times 28, which is 784. And 96 times 96 is 9,216, and that's going to equal c squared. So we have some like terms on the same side, so we're going to go ahead and add those like terms, and that gives us 10,000 equals c squared. But we're not looking for c squared, we're looking for c, so we do that inverse operation of square rooting, and that will give us c. And the square root of 10,000 is 100. And so now we know that the length here on our diagonal is 100 feet. Now we're going to go back to that question. It says, how tall was the redwood tree before it fell? So what I want you to kind of imagine is, where was it before it fell? Well, we know that this part is 100, but that's not how tall the tree was. That's just the broken part of the tree. The other part of the tree is up here. Well, down here, that's not part of the tree. That's just the ground. So we're not going to include this value because that's not part of the tree. The tree is from the ground up to the broken part all the way to the tippy top of that tree, which is now fallen down. So we're going to add the hypotenuse and just the one leg. So we're going to do 100 plus 28, and that will tell us 128 feet would be the length of the original tree, or the height rather. All right, and then the next one, it says a 26-foot ladder is leaning against a building with the top of the ladder, so the top of the ladder touching the exact top of the building. So it says the ladder is 26 feet. Well, I can see the ladder here, and your ladder is always going to be at an angle, okay? So it's always going to be diagonal because ladders don't go straight up and down. Otherwise, they would tip over when you got on them. So your ladder's 26. And if you remember, diagonal is also considered our hypotenuse. You might also recognize on the picture, this is our right angle here. And it says the bottom of the ladder is 10 feet from the building. Well, here's the building. So from the bottom of the ladder to the building is 10. So that's one of our legs. And it says, how tall was the building? So our height of the building is our A or B value. So it's one of the legs, because again, here's our right angle. So we're going to do A squared plus B squared equals C squared. So I'm going to say my unknown's A squared. B is our 10. Oops. Excuse me. And C, which is our hypotenuse, they gave us as 26 because that's the diagonal length. So we're going to go ahead and we're going to find what all these values make. So A squared stays that. 10 squared is 100. 26 squared is 676. Now I need to move our like terms to the same side, but because it's on the opposite side of the equal, we need to do the inverse to move it over. That's our 0 pair. Now I have A squared. I'm going to go ahead and subtract those, and I get 576. We're going to do the last step, take the square root of both sides. That gives me simply just A, and the square root of 576 is 24. I'm going to make sure that's what they're asking. How tall is the building? And remember, that was the length that we just found, which is 24. Good job.